Okay, lads. So what we have is 12e. Okay, wants us to solve a pair of integrals. Okay, so it wants us to solve that dy dx equals 3y. Now you see that's going to give you a bit of information here. We're just going to wait a minute to use that information. So we're going to do is what we did in 12d. We're going to cross multiply down the y and bring up the dx. So we're going to have 1 over y dy equals 3dx. Okay. Now what we can do next is we can match up limits. So do you know why we usually integrate both sides and have a constant of integration, yeah? So what we can do is we can match up limits that when the limit for y equals 1, the limit for x has to be equal to 0. And then we can use standard letters for if it's a dx you can use an x, and if it's a dy you can use a y. Is that right? Now integrate 1 over y dy and we get anybody remember what happens when you integrate 1 over y? ln y, log to the base ey. Okay, so ln y is 1 over y, and that goes from y to 1. Integrate 3. Anybody? Sorry, I was meant to put that there. 3x, and that goes from x to 0. And look what happens next. We're going to get ln y minus ln 1. Anybody know what ln 1 is? You don't have 0. Okay, so ln y equals, it's going to be 3x minus 3 times 0. Minus 3 times 0 doesn't have to be there. Now, what is ln? What does it mean? Log to the base e, y, 3x. Then bring up your log function, and what happens is the e becomes the base number, and the 3x is the power. So you get y equals e to 3x. Alright? Now, these are going to be our bread and butter very soon, that we'll just be able to fly through these and there won't be too much hassle. I'll go to question 3 now. So 1 followed by 3. So question 3, solve this. Okay, I'm going to bring the 1 over y squared underneath. I'm going to bring the dx up. So we're going to get 1 over square root of 1 minus y squared dy equals 2x dx. Can anybody tell me how to do the limits for this one? What goes in this position here? Huh? When y is 1, x is 0, and then we know that the whole point of the question is to get x in terms of y, so the upper limits are x and y. And what this will do, it'll create an equation of y in terms of x. So, anybody know how to integrate this? It's 1 squared minus y squared, so 1 over square root of a squared minus x squared is sine inverse x over a. Is that right? Sine inverse x over a. So what happens now? Anybody tell me? Sine inverse y over 1. There's no need for the 1, so we can get rid of it. Then after that, equals integrate 2x x squared, and that is from y to 1, and this one is from x to 0. Okay, now guys, what do we get next? So sine inverse, it's going to be sine inverse y minus sine inverse 1. Anybody know what sine inverse 1 is? Pi over 2. Now it's you're not going to put 90 degrees down there. You're always going to use radians when it's in the formula. Okay. And then the other side, we're just going to have x squared minus 0 squared, and then that's grand there. Okay. Move the pi over 2 over the other side. We get sine inverse y equals x squared plus pi over 2. Anybody know how to finish it off there? What'd you say? Y equals? Hey, you got it right, I think. Sine x squared plus pi over 2. For those of you that are struggling to get that into your head, if I had tan inverse 1, and we know tan inverse 1 equals pi over 4, if I move the tan over the other side, it's 1 equals tan bracket pi over 4. You can see when tan inverse crosses over the other side, it turns into tan, and whatever is on the other side ends up to be the angle for that trigonometric function in question. Okay, so that's 1 and 3 done already. Question 4 is quite easy. It just doesn't use y, it uses t instead of y, so it's quite easy as well. Now, I'll try something a bit more. Question 6, just mix up the letters a wee bit and might be considered a bit more confusing. The SDT plus sine t over s equals 0. Bring the sine t over s over your side, yeah? And then what do we get then? Minus sine t over s. Cross multiply. S ds ends up to be minus sine t dt. What happens after that? Integrate both sides. Now, when we integrate both sides, guys, what's the limits? For ds, it's root 2. For the t, it's pi over 3. And then t is the variable over this side, and s is the variable over this side. Integrate. Integrate s, and we get a half s squared. And then that ranges from s and root 2. And then the other side is what happens when you integrate sine t. I always forget. When you integrate sine t on its own, so it's going to be this minus here. The minus I'm putting down now is the minus from the original formula. And then when you integrate sine t, you get minus cos t. What happens when we differentiate the angle? Differentiate the t? 1. So it doesn't have any effect. If that was a 2t, there'd be a divided by 2 underneath that. If that was a 4t, there'd be a divided by 4 on the bottom. Okay? But it's not. And then it's t and pi over 3. And then cross, just do the limits, a half s squared minus a half times root 2 squared equals, just get rid of these two minuses for a second, just cos t, and then put in t, go cos t minus cos pi over 3. What is cos pi over 3? Let me remember. It is 60 degrees. 60 degrees means the adjacent is shorter than the hypotenuse, or opposite. I'd go for a half. We'll try out. Whoop. Radian mode. Cos. Then we get yeah. Where's the pi button? Half, yeah. So cos t minus a half. Now, multiply both sides by 2. Cancel, cancel. 2 cos t minus 2. Bring the everything over one side. So 2 cos t plus 2 equals s squared. S therefore equals the square root of 2 cos t plus 2. Now, something that you're always going to notice, do you know when you're given ds dt, yeah? It's always s in terms of t. When you're given dy dx, it's always y in terms of x, not x in terms of y. So do you understand, whichever one is on top is the one that gets on its own. The other ones don't. Okay. Question 8 and question 10, then followed by 12, followed by 14. Okay, that should be a decent spread. Okay, question 8. Okay, y over x squared dy dx equals 1. How would you start this one off? Any idea? Huh? Bring the x squared, and what else goes with it? The dx. What stays on the left side? Okay, then after that, this is a very easy one. Looked a lot worse than it is. What's on the bottom? What goes on the bottom here, guys? Here, here, here. Come on. See it sticking. And then after that, integrate y. Half y squared, y to 0. Integrate that one. X cubed over 3. X to 1. And then what we get here is a half y squared minus a half times 0 squared equals x cubed over 3 minus 1 cubed over 3. I'm going to multiply, going to give everything a denominator of 6. So that means 3 top and bottom here. That doesn't exist. 2 top and bottom here. And when I do that, I'm going to get a 3y squared equals 2x cubed minus 2. Bring down the 3. 2x cubed minus 2 all over 3. And then y equals the, we'll just put it to the power of a half, or square root sign it, whichever is good. Same thing as a square root sign. Okay. Oop. Okay, what one was that? Number 8, yeah. They factorized out the 2 on top. So what they would have done instead was they would have, in the solutions in the back, they say 2 times x cubed minus 1. And then the 3 stays on the outside. And then it's the square root of all that. Same stuff. Okay. 10. 10 looks decent. Any ideas what to do with 10? What's the first thing you'd do? Step 1 is you always get dy dx on its own side of the equal sign. Anything else that's preventing that from occurring needs to move over. Okay? So you have 1 over x minus y over x. What can I do with these two fractions? Plus y over x. What can I do with these two fractions? Plus y all over x. Step after that, dx up and d, 1 over y down. 1 plus 1 plus y dy equals 1 over x dx. Now, do you see the way this entity here, see the way it has 2 parts? Yeah? See the way it has a 1 and a y? You can't do 1 plus y to the power of minus a half there. Or sorry, you can't do that to the power of minus 1. You have to use log functions to integrate that. Now it's also asked about another potential move. What happens if it's 1 over square root of 1 minus y? The fact that there's 2 objects in the square root sign blocks you from using the negative power rule, like 1 minus y to the power of minus a half. You can't do that. You're always going to use the sine inverse function for square root signs, and you have something like x squared plus 5 on the bottom. You're going to use the tan inverse function. So basically, you're never going to have a chain rule. You're never going to be looking at a chain rule situation where you have to figure it out. It's going to be log, tan inverse, or sine inverse every time, without fail. Now, what happens here, guys? What's your choice for 1 divided by a variable on the bottom? Log. And what about our limits? 5 4 and 0, right? So 4, 0, y, and x. Give it a go. ln 1 plus y from y to 0, and then equals ln x from x to 4. Now, you're going to get here is ln 1 plus y minus ln 1 plus 0, which is ln 1, equals ln x minus ln 4. What's ln 1? Okay, ln 1 plus y equals. Now I'm going to use which rule would be a good rule for combining the two of these? Sorry? Yeah, the division rule of logs. So it's x over 4. When there's a takeaway sign in between two logs, it's the first one divided by the second one. What's very similar on both sides here now, guys? They both ln, aren't they? So the ln's technically, it's the same function, so must mean that 1 plus y equals x over 4. Therefore y equals x over 4, take away 1. Okay. Two more, and then I'll let you guys have a crack at them for the rest of the class, okay? So, what about number 12? xy dy dx, anybody? Equals y squared. Any guesses? Bring the x underneath. So it's 1 over x. Bring the dx up. So that gets rid of my x and dx. They're gone. Now what about the y squared? Bring it underneath. Y over y squared. Sorry. 1 over y to y. They're just dressing up log, aren't they? As best they can. And then once that's done, it's 2, 1, x, y. And then ln y. Y and 2. ln x. X and 1. ln y minus ln 2 equals ln x minus ln 1. ln 1 is 0. ln x, and that's ln y over 2. What's next, guys? Y over 2 equals x. Y equals 2x. They're not really getting any harder. Oh, sorry, there is a 16 and 7 then.